In this video, we are going to see the mechanism of breathing. Respiration consists of cycles of inspiration and expiration. In simple way, inspiration is the process of breathing in of air and expiration is the process of breathing out of air. And this means the mechanism of ventilation. During inspiration and expiration, there are certain movements in the thoracic region. Before we discuss in detail about these movements, let us have a quick insight into the structures that is supporting the respiratory system physically. The respiratory system is physically located in the thoracic region, that is the upper body, and it is surrounded by rib cage. The thoracic region is separated from the posterior abdomen by a dome shaped muscular tissue called diaphragm. Diaphragm forms the floor of the thoracic region. The process of respiration is supported by this structure also, which we will be seeing in the next few minutes. Before we discuss the mechanism of breathing, let us have a close look at the layers of lungs. As mentioned before, the lungs are housed within the ribcage of the cavity. Pleural membrane is a thin, slippery, double layered membrane that lines the lungs. The outer or parietal pleura lines the inside of the rib cage and the diaphragm. They forms the outermost layer of the lungs, and the inner or the visceral layer covers the lungs. So they are going to be in continuous with the lungs. Between these two layers are the interpleural space, which accommodates a fluid secreted by the membrane. The pleural fluid is the fluid that is secreted, and it serves as a lubricant during the mechanical movement of the lungs, because lungs is going to be in continuous movement as we breathe in and out. The two layers of the pleura remains tightly adherent to one another. This helps as a support to the movement of chest wall during respiration. Lung exhibits elastic properties. This elastic property of lung is called as elastance, and it results in the process of inspiration and expiration. During inspiration, we inhale. So during inhalation, the diaphragm, which forms the floor of the thoracic cavity, which was originally dome shaped, when it is in relaxed condition, will start contracting and they become flattened. This allows a vertical increase in the volume of the thoracic region. Then the intercostal muscle, specifically the active external intercostal muscles that is lining the ribs, are contracting. This allows the pulling and stretching of the rib cage laterally. So the chest wall will move outward and upward, resulting in lateral increase in the space. So as a whole, the lung volume increases and the pressure within the lungs decreases. So eventually air from the external atmosphere is drawn into the lungs. During expiration, the diaphragm relaxes and takes back its original dome shape, thus results in decrease in the vertical space as they tuck into the thoracic cavity. The chest wall, which was pulled outward and upward due to the inspiration are brought back to their original position by the contraction of the internal intercostal muscles. Thus, the lateral volume of the rib cage is reduced, the volume within the chest is reduced, hence the pressure inside the chest is increased than that of the atmospheric pressure. Eventually, the air within the lungs are expelled out by the process of expiration. The picture shows certain other muscles that supports directly and indirectly to the process of respiration. As we were discussing on the mechanism of respiration, we came across these terms like difference in pressure and volumes. Yes, it is this difference in pressure that is actually the key player of this mechanism of respiration. The pressure within the lungs is compared to the pressure in the atmosphere. So, when the atmospheric pressure is more than that of the internal pressure, air is drawn into the lungs and vice versa. So, the other two pressures which have clean interest here are the intra-alveolar pressure and intrapleural pressure. Intra-alveolar pressure is the pressure within the alveoli, and intrapleural pressure is the pressure difference between the visceral and the parietal layers of your pleural membrane. So, this difference between the transpulmonary pressure and the intrapleural pressure is the driving force that enables the air to reach the terminal end of the respiratory zone, the alveoli, where the true process of respiration, that is the gaseous exchange, is taking place. So, this intrapleural pressure becomes more negative at increased stage of inspiration, like at the maximum inspiration. To summarize, and it is about minus 6 mm of Hg, and it is the highest negative value, thus drawing the air to the terminal end of the respiratory tract. The expiration is initiated by the increase in the pressure of the interalveolar space, and it becomes positive nearly about plus 3 mm of Hg, and compared to that of the atmospheric pressure, which is 0 mm of Hg. So, the internal pressure is higher than that of the external pressure, resulting in the movement of air out of the lungs. To summarize, the volume of the chest increases, the pressure inside the chest decreases, and it results in the process of inspiration. And the volume of the chest decreases, pressure increases, results in exhalation process. This is the mechanism of breathing. Thanks for watching. In the next module, we will discuss the lung compliances, lung wall